Greetings and welcome once again to my new calculus channel. So further to my previous video, I got some common questions again about square root 2, pi, etc. I mean, people simply don't pay attention to detail. Okay, so I'll answer some of those questions and then I'm never going to address them again. So unless you pay very careful attention now, you've lost out forever. Okay. Now, many of you asked me, what is square root 2? Well, square root 2 is not a number, by the way. It's not a number of any kind. Okay. So look, how did the Pythagoreans realize square root 2? Well, they had algebra, by the way. It just wasn't known as algebra. So if any East Indian or Arab tries to tell you that they invented algebra, they're a bunch of liars. They didn't invent algebra, and they didn't invent the arithmetic operations, and they didn't really contribute anything meaningful to mathematics. Zero is certainly not, it's useful, but it's not necessary in mathematics. Okay. And most of their ideas are basically of zero worth. The main concepts came from the most brilliant people who ever walked the surface of this earth. They were the ancient Greeks. Okay. So how did the Pythagoreans realize the concept of square root 2? Well, in geometry, you can measure any value you like with a physical unit. So for example, if we assumed that this side here was the unit, okay, then we could measure the hypotenuse with this unit. It would be that much plus this little bit here, okay, plus this little bit here. And it's measured, it's complete, because geometric measure says that you use a physical unit and or parts of a physical unit to measure another magnitude, okay? Now in algebra, that's different. In algebra, what you try to do is you try to measure this line. Okay, let's look at the algebra one. In algebra, you try to measure this hypotenuse using equal parts, using this whole unit and or equal parts of this unit. So maybe you take one and then equal parts of this unit to measure the rest. Problem is, we can prove very easily that there are no divisions of this abstract unit because it doesn't matter what right angle you take. If you try to measure the hypotenuse with this side here, you will still realize that symptom of square root 2, okay? In other words, you try to measure it, you'll in any base. In base 10, you get approximately 1, 1, 4, 1, etc., okay? But that's not square root 2. Okay? That's just a constant that we use in place of square root 2. Now, another misconception is that if you say square root 2 squared, you've actually done an arithmetic operation. Well, you have in a sense, but you haven't also, because you haven't touched square root 2. You're operating only on the index, okay? So if you have 2 to the half and you raise it to the power 2, that's all you're doing. You can have more on inside here, or apple, or object. Object to the half, hang on. Object to the half squared. That's just object. It doesn't even have to be a number, okay? So square root 2, by the way, is not a number. It's not a number of any kind. The constant you think of as 1.141, etc., is a number, but it doesn't represent square root 2. It's an approximation for this failed measure. In other words, the failed measure is this. It's square diagonal. This is a ratio. Square diagonal, square side. Okay. In other words, you're trying to measure this ratio, and you can't. What you're saying is that it's equal to square root 2, but it isn't. Okay. It fails. You can't do it. Now, another question I get is, why can't there be an infinite decimal expansion? Well, think about it. Think about it. When is any infinite decimal expansion unique? Okay, think about it carefully. When is it unique? The answer is never. Okay, your idiot math professors and teachers don't tell you this, but doesn't matter which infinitesimal expansion you talk about. The one that you think for root 2, for pi, for e, or anything else, none of those are ever unique, okay? Because, as I said, if you, for example, say this, just put a 0 and a 9, then you could put a tree at any particular unit you like, and this new number will have the same digits in the same n places as pi, okay? So this BS here, doesn't matter if you take it to trillions and gazillions of units, is not pi. It's not equal to pi, okay? Not equal to pi. That's BS. So now what else was I asked? So square root 2, pi are typical questions that I get asked. Then people, you don't understand that k divided by 1 may not necessarily be equal to k. Why? Now, as I explained to you here, let's make some space. In algebra, we use the abstract unit and or parts of the abstract unit, okay? So unless you can measure a particular ratio, so if k is the measure of a ratio, measure of, let's say, that, and you can actually measure this ratio, right? In other words, what does it mean to measure this ratio? It means that this antecedent and consequent have a common divisor. It doesn't have to be a number. It could be just something that you measure. It could be, let's say, that part there, and it measures this part without measure and this part without measure. No, nothing about numbers. But algebra comes in when you start counting these little parts, okay? So let's say this is something like this. There are no spaces there, but I'm just putting them in to make it easier for you to see. So say, for example, this is a joint one line and this is another line. And we notice that with this part of the antecedent, this part of this line, we can measure the consequent and the antecedent. Then we think, okay, in algebra, we'll use that as the abstract unit. We'll say 1, 2, and this one here, 1, 2, 3. So k is 3/2, which is the measure of this ratio, okay? So now, unless k is the measure of a ratio, it's not a number. So you can't say k is equal to k divided by 1 unless you know that k is the measure of a ratio. Because if k is pi is not equal to pi divided by 1. Square root 2 is not equal to square root 2 divided by 1. Okay? Why? Because this means that you can measure pi with 1. Do you understand that? That means that you have a circumference and a diameter, like that, and that using the diameter as unit, you can measure pi and equal parts of it. You can't. So this statement here is wrong. Now, those baboons who are known as your math lecturers and teachers don't know these things. They're morons, and they've been brought up and trained incorrectly on the bullshit of Cantor's set theory, this idiot, and the ZFC axioms. None of that is mathematics, okay? So this is the final video I'm going to be producing on this stuff. If any of you ask me again about this thing, you'll just be, your comment will at first be removed. The second time it will be removed again. The third time you'll be banned because I don't like going over things. Geniuses do not like repeating themselves, okay? So you either study the material or you just move on. Go to another channel. I really don't give a fuck what you believe, what you think. You're an idiot next to my intelligence. You have nothing to tell me. Be very careful about getting on here and trying to lecture me, you little pipsqueak, or you incorrigible professor of calculus moron. You're all idiots compared to me. And you deserve to be called that because you are incorrigible and you will not be corrected. I will give you links to all these videos and articles, but what I recommend you do is buy the Ultimate Book of Numbers, which explains all these things and much, much more. It's only $9.99. And then, of course, my latest project will open your eyes to mathematics like they can't be opened by anyone else. That's a big statement, and I stand by it. Okay, this book here is one of the most important books ever written. Okay, it's called The Importance of Learning the Right Way, What does division mean in mathematics, and how does it affect all other arithmetic concepts? it's not just about that. It's about also my theory of learning and how it ties in, and how what you learn affects the way you learn things in future. It can actually, your wrong learning can traumatize you to an extent that you cannot learn the right way anymore, and you cannot progress. So a lot of these mainstream math professors and teachers, they're beyond help. They cannot be helped anymore. Their brain is at a stage where they've learned the wrong way all their lives. They don't know what they're doing, and they cannot be corrected. Doesn't matter how much evidence you provide to these people. They're cranks, and a crank cannot be convinced in the face of overwhelming evidence. If you're not already a subscriber to my channel, become a subscriber. Click like. Follow me on academia. I've written thousands, hundreds of articles actually, and one free book. My new calculus book on here is free, though it's not as good as the one I am selling on Amazon. This year is again also $10, and it contains what is the new calculus in a limited number of pages. But this here is extensive and was put together very haphazardly from some papers that I used to write. So that's pretty much it. My name is John Gabriel. Till next time.